going to be talking about factoring by split the middle today. So when we split the middle, we have learned three other factoring methods. We have learned greatest common factor, which is the first thing we always have to look for when we do factor. We have learned about factoring by difference of squares, and we have also just did the factoring method of grouping. So all of those factoring methods work in specific cases. This fourth method works in a specific case as well. The general method for a quadratic equation is ax squared plus bx plus c. A, b, and c here are just numbers. So this is a trinomial that would look something like this. 2x squared minus 4x plus 5. So the a, b, and c are those numbers there. All of these equations, all of these polynomials are trinomials. Okay? Remember, a trinomial is a polynomial that has three terms. We must have three terms in order to use this factoring method. There has to be a squared term, an x term, and a constant. Now, for equations that are in this standard form, we could use a method called guess and check, which is exactly what you think it is. We're going to guess some numbers and check to see if it works. However, that takes a long time. So we're going to use the method called split the middle. All right, and let's see how split the middle works. All right, so we're going to do a couple longer examples here with a lot of description of how we do this, and then we'll speed it up. So for the first problem, we have a trinomial 6x squared plus 23x plus 7. The first thing you're going to do is, for this problem, label A, B, and C. Those are the coefficients on the polynomial. Now, the first thing you have to do is you have to figure out what is A times C. Here that's 6 times 7. Right? Well, 6 times 7 is 42. And what our goal is when we split the middle is to find two numbers that multiply to 42. So what we're going to do is I'm going to make a little list of all the factors that we can think of that multiply to 42. So start with 1. 1 and 42. 2 and 21. 3 and 14. And 6 and 7. From that list of numbers, that's the first thing we did, was we found the numbers that multiply to 42. We need to find a pair of those numbers that add to give us the B term, 23. So when I look at my list, it looks like 2 and 21, if I added them together, would give me 23. Okay, so we want two numbers that multiply to 42, and add to the middle number. So what we're going to do is we're going to rewrite the original polynomial. Okay, so we're rewriting this polynomial down here. When we do that, the first term, the 6x squared, and the 7, they stay the same. The only thing that changes is the 23x. And we're going to rewrite that as 2x plus 21x. Okay, we're using the two numbers we found that add to 23 to rewrite it. Now, if you look, we have 1, 2, 3, 4 terms. And yesterday we learned a factoring method for 4 terms called grouping. Excuse me. So with grouping, we're going to group the first 2 terms together and the last 2 terms. Find your GCF for each group, and then we'll be all set. So first, 6x squared plus 2x. The GCF there will be 2x. So we're going to divide a 2x out of both terms. We put the 2x in front. When you divide, you'll end up with 3x plus 1. Remember, anything divided by itself is 1. And on this side, we're going to divide 7 out of both. A positive 7 because this sign is positive. So we'll have a 7 times 3x plus 1. Remember, that's a good thing here because both of those parentheses look the same. So what you have as your final answer is 2x plus 7, those GCFs in front, times 3x plus 1. That's our final factored form. Now, we do want to be able to check these. Remember, factoring is a form of division. So if we're going to check our work, we're going to do the opposite and distribute. So let's do that really quickly here, just to make sure we see what we did. So we'll take 2x times 3x, which is 6x squared. 2x times 1 is plus 2x. 7 times 3x is plus 21x. And then plus 7. And you can see that if you combine these like terms here, 2x and 21x, you get 23x, which is exactly the same polynomial that we started with, which means that you factored this correctly. All right, let's try another one. This time we have x squared minus 3x minus 18. And I want to point out that when there's just an x squared in your polynomial, the leading coefficient is 1. That's your A, 1 here. B is negative 3. C is negative 18. Again, the first step is to multiply the first number and the last number. 1 times negative 18. All right, so we want to find two numbers that multiply to negative 18. Okay, when I make my list, I want two numbers that multiply here. So I'll make a longer list this time. Usually I won't make all the positive and negative options, but for this one I will. You could have negative 1 and positive 18. Remember, when you multiply to be a negative, you need one positive and one negative. You could have negative 2 and 9. And you could have negative 3 and positive 6. Or the opposites could be on the other number. You could have positive 1, negative 18, positive 2, negative 9, positive 3, negative 6. Okay, so we multiplied our numbers, and I now need to find two numbers that multiply to that negative 18, which I found, that add to the middle number of negative 3. All right, so it looks like here we're going to use 3 and negative 6. Right, 3 minus 6 is negative 3. So those are the two that from my list that I'm going to use. Now that we've done that, we're going to rewrite our trinomial. The first term is the same, x squared. Then I use plus 3x minus 6x, and the negative 18 stays the same. Again, we're going to start by factoring by grouping, first and the last terms. From the first group, they both have an x in common, so that's what we're going to divide out. We pull out the x, and we're left with x plus 3. Now, in this second one, there is a negative on the third term, so our GCF is going to be negative here. And it looks like I can pull out a negative 6 from both terms. When I do that, negative 6 divided by negative 6 is positive 1x. And over here, negative divided by negative is a positive 3. Looks like we have two parentheses that are the same, so those come down, x plus 3 times the GCFs we pulled out, x minus 6. Again, that is your final answer. We can check our work by factoring, or not factoring, by distributing really quickly. X times x is x squared. X times negative 6 is minus 6x plus 3x minus 18. And if you combine these middle terms, negative 6 plus 3 is negative 3x. And it looks like we have the same polynomial that we started with. Oh, hold on, I multiplied wrong. I didn't multiply wrong, I wrote the wrong number. But now it looks like we have the same thing that we started with, which is good work. So that's our factored form. All right, let's try a few more problems on the back here. Only a couple more. 2x squared minus 7x minus 9. All right, the first thing you do every time is multiply the first number and the last number. 2 times negative 9 is negative 18. So you want to find two numbers that multiply to negative 18 and add to negative 7. Okay, this is our goal to add there. So when I list out these numbers, it's going to be the same set we used last time. We'll have negative 1, positive 18, negative 2, positive 9, negative 3 is 6, and then we reverse the negative because we need one positive, one negative. So we can do 1 negative 18. Alright, so that's our list of numbers. From that list, I need two numbers that are going to add up to be negative 7 this time, the middle term. And it looks like I'll have 2 and negative 9 here that I'm going to use. So when I factor, the first term comes down, the last term comes down. the middle terms get split up into the 2 and negative 9. So we rewrite this as plus 2x minus 9x. Now I have 4 terms, so I can group. I group the first 2 terms together and the last 2 terms. From the first group, it looks like my GCF here is 2x. So I pull that out in front, and you're left with x plus 1. Remember, 2x divided by 2x is dividing by itself, so you get a 1. Because the sign here is negative, you're going to be factoring out a negative. Looks like a negative 9. When I divide by negative 9, I'm left with x, and then when I divide anything by itself, I get 1. The final answer then is going to be 2x minus 9, x plus 1. And that's your final answer. Okay? Again, you could check by using the distributive property. Number 4, I have 6x squared minus 13x minus 5. I start always with multiplying the first number and the last number, negative 30. So I need to find 2 numbers that multiply to negative 30 and then add up to negative 13. When I list out my numbers, I'll have negative 1 and 30, negative 2 and 15, negative 3 and 10, and negative 5, 6. Reverse the positive and negative, and we'll have our complete list. From that list, let's see, we need 2 numbers that add to negative 13. Looks like we're going to use 2 and negative 15. 2 minus 15 is negative 13. So I bring down the 6x squared. I bring down the negative 5. In the middle, I split that up with the 2x minus 15x. Now I'm going to group. Same process now. Hopefully you're good at grouping, and then this will go quickly. Here it looks like my GCF is 2x. So I'll have 2x times 3x plus 1. Again, this term is negative, so I'm pulling out a negative GCF. Looks like a negative 5. Negative 15 divided by 5 is positive 3. And negative 5 divided by negative 5 is a 1. So your final answer is 2x minus 5 times 3x plus 1. And you're all factored. All right, let's try 2 more. 7x squared minus 9x plus 2. Multiply the first and the last. 7 times 2 is 14. Now it's a positive 14 this time. So it's a little easier. I need to find 2 numbers that multiply to positive 14 and add to 9. Negative 9, I'm sorry. Well, let's think about positive 14. I could have 1 and 14, 2 and 7. However, when I have 2 numbers that multiply to a positive, they could be both positive. Positive times a positive is a positive, right? Positive times a positive gives you a positive. But I could also have a negative times a negative to get me a positive. So my other combinations I could have here are negative 1, negative 14, excuse me, negative 2, negative 7. So when I look at those, the ones that are going to add up to give me negative 9 like I want are negative 2 and negative 7. So I'm going to put those into my factored form here. 7x squared and the 2 stays the same. I'm going to bring in minus 2x minus 7x. Okay. Now, we're going to group. From the first group, it doesn't look like 7 and 2 have a number in common, but they have the variable x in common. So I pull out the x, and you have 7x minus 2. The x's cancel off there. Here again, I'm negative, so I pull out a negative GCF. And this time it looks like just a GCF of negative 1. We haven't done one of those in a while. When I divide out negative 1, all it does is it changes the signs to be positive 7x minus 2, which does end up working, matching the other set of parentheses. So your final factored form is 7x minus 2 x minus 1. All right, one more here on our notes. X squared plus 9x plus 20. I have a leading coefficient of 1. So when I multiply these, I need two numbers that multiply to give me 1 times 20, which is 20. All right, again, when I'm trying to find a positive, I can have either two positives or two negatives. So we'll have 1 and 20, 2 and 10, 4 and 5. Make all of those negative. And I need to find a pair of those numbers that add to positive 9. Looks like 4 and 5. So what you're going to do is, just like the last column, you're going to bring down x squared, you're going to bring down 20. You're going to split the middle part with 4x and 5x. And finally, you're going to group, and you're almost done. The first group looks like it just has an x in common. So you'll have an x times x plus 4. And here, since this term is positive, your GCF is going to be positive. Looks like I can bring a 5 out of both of those. So we'll have x plus 4 in those parentheses. That means your final answer here is x plus 5 times x plus 4. Remember, you can check your answer by distributing. All right, those are the notes. There's a quick practice at the bottom. There's also 2 extra practices on split the middle. If you have questions on any of it, check the key on Canvas or ask your teacher for help.